Hey everyone, welcome back to the YouTube channel. If you are new here, I am Mithul Saswika, and in today's video, we are going to talk about one of the most important and interesting topic in data structure, the AVL tree and how node insertion work in it. You guys, AVL tree is like a tree? No. So if you have already watched my previous video about merge sort, then you are going to love this one too, because AVL tree take what we learn about sorting and search and then make it faster and smarter. So before I tell you what is merge sort, it's look like same now. So let's jump right in. So let's talk about what is an AVL tree. The AVL tree is a type of self-balancing binary searching tree. Now you might be wonder, what does self-balancing mean? Well, in the normal binary search tree, BST, we insert node in a specific order. The smaller will to the left and the larger will goes to the right. So you may think, what is BST, not a binary search tree. So now I am explaining what is the binary search tree. First, quickly remember what is binary tree. So binary tree is has a small property. The left child is less than parent child, and the right child greater than parent. So it's work great, but sometimes tree become unbalanced. So like this. Then for example, if you insert number in sorted order like 10, 20, 30, 40 like that, the BST become the long linked list. So the last example I show you. So that's the BST simple idea. Let's continue our AVL tree. It's fine. For the AVL tree example, imagine insert node in according order like 10, 20, 30, 40, 50. What happened? The tree become a squid, mean it start looking like a long linked list inside of a property. The before I told BST like that. That's a problem, because search, insertion, deleting all become slower, almost like working with the least inside of the tree. So so here become the AVL tree. It was invented by Adelson and the Leidens in 1968. That's the name become AVL tree. So it's automatically balance itself after every insertion or deletion to keep the tree efficiency. So now we're going to talk about balance factor in AVL tree. The heart of an AVL tree is a balance factor. Every node in the AVL tree has been balance factor that helps to tree to know if it is balanced or not. So this is the calculation how we can calculate balance factor. First, what we have to do, height of left subtree subtract in height of right subtree. So now you want to remember this. If the balance factor is 0 of the tree is perfectly balanced. If it is plus 1, the left subtree is bit higher. If it is minus 1, the right subtree is the bit higher. I show you example. This is the example I got. It is a tree lower is perfectly balanced. So if we use the balance factor, the right side also have a 3 trees and left side also have 3. If we divide that, subtract that, it will become a 0. I already told that 0 is a perfect balance. So next get -1 or +1 example. This is the example. So if that, the right side have only 1 tree and the left side have 2 trees. If we subtract that, the factor become a 1. It means the left side subtree is biggest than the right side. So that's the idea of the balance factor. But if the balance factor becomes the less -1 or greater than +1, the tree become unbalanced and we need to fix using rotation. Now we are going to talk about rotation time. Earlier I said the tree become greater than -1 or greater than +1. We have to balance it. We have to fix it. So now we use that rotation type. Rotation are the sector weapon of the AVL tree. They help restore balance when the tree become unbalanced. There are 4 type of rotation you need in the balance the system. First one is a right balance. Second, left balance. Left right balance. Right left balance. LL, RR, LR and RL. First we talk about right rotation, LL case. This happens when you insert a node in the left subtree of the left child. It's meaning the tree learns too much the left. It means the left side become too long. So for example, if you insert 30, then 20, then 10, now the left side is too heavy. To fix this, we prefer the right rotation on the unbalanced node. After the rotation, 20 become the new rule and the 10 is the left and the 3 move to the right. So I'll explain it using step by step in easy way. So please listen this after I tell you. Boom, now it's balanced again. So left rotation, RR case. This is the opposite of the right case. It happens when I insert a node in the right subtree of the right child. So the tree learn too much to the right side. So example, insert 10, 20, 30. Now the right side is too heavy. So we fix this by performing a left rotation. After rotating, 20 become the root, 10 the left side and the 30 goes to right side. So again it's balanced. So next we're going to talk about left right rotation. Left right. So it is same as the others. So this is the one, the mix of left and right side. It happens when you insert the right subtree of the left child. So example, first insert 30, then 10, then 20. Now the left child is 10, has a right heavy subtree 20. It means, so if we want to fix, first prefer a left rotation on the left child and then perform a right rotation for the right. This one we use, so simply we use the right side in the right side, left one is get unbalanced, we use this left right rotation. So it is a bit hard, but please listen to this. So after the both rotation, the tree become perfect balance. So next go to the right left rotation. It is the opposite side of the left right rotation. So it happens when you insert the left subtree of the right child. So okay, for example, insert 10, then 30, then 20. This become a 10, 30, 20, like that. Fix this. First perform a right rotation on the right side. Right rotation. Before we learn how to do a right rotation, we do the right rotation. Then next we do the left rotation for the right one. And then boom, it's again balanced. So that is the rotation meter. So now we going to learn AVL insertion step by step. So early we talk about this insertion and how to rotation works. So there are, we insert new nodes, we do three things. We do three things. So first we need to insert the node, just like we do in a binary search. Update the height of the all nodes affected by the insertion. Check the balance factor and perform a rotation if need. So earlier we talked about binary search tree, the like insert 10, 20, 30, like that. Then we update the height of the tree. So tree height is 3. So next we check if we want to balance them using the balance factor, and then we use rotation method to correctly balance the tree. So let's take a small and clear example to understand this. So let's go to example. So forget the example, we firstly insert 10, 20, 30, 40, 50 and 50 and 25, like that. First we have to do insert 10 to 3. Okay, then next the tree is empty and the 10 become a root right now. So next we insert the 20 to the 10. The 20 is greater than 10, so it's get the right side. The tree is still balanced. Okay, so next we insert 3. It goes to the right side of the 20 because the 30 is greater than 20. So now the tree will become unbalanced. For the fix it, we perform a left rotation. At the 10 goes to left side and 30 goes to right side. 20 become a root. So like this. So next step, we insert 40 to the tree. The 40 goes to the right side of the 30. Now still it becomes balanced. So next we insert 50. It goes to right side of the 40. So now it's get unbalanced. For we have to perform a left rotation like this. 40 goes to up, 30 goes to left side and 50 goes to right side. Now it's balanced again. So next we insert 50. So sorry, 25. So 25 goes to left of 30 because the 25 is less than 30 but greater than 20. How it's work? This is the main point you want to learn the higher values. It means if we get 20, 40, 30, 50, 25 is higher values, goes to the right side, and the smaller values, it means 10 goes to left side. So like this example. So this is the small example in this AVL tree. I hope you understand this example. So Now we're going to talk about time complexity. One of the main reasons why we use AVL tree is efficiency, fast, performance, like that. So there are three types we do: search, insertion, deletion. There I have, we use a search or logging in, insertion or logging in. So like that. Deletion also have the same. So because the tree always stay balanced, no operation even take longer than log arithmetics time. So this is a time efficiency. I know it's a bit complex to understand. So like that. If we get real life example, AVL tree are used anyway, balance and speed in an import. For example, in a database to maintain a fast access to record. In a memory indexing and file system, we are perform and matrix. Even in a compile design for simple table management. So next time you hear about the balance trees, remember AVL tree are one of the earliest and easiest and most reliable way to keep think efficiently. So this is the final of the video. Alright guys, that's the today video, and I think step by step you guys learn what is an AVL tree. If this helped you understand the concept clear, don't forget to like, share and subscribe, and drop a comment if you want to meet and explain AVL tree and the other tree, real black trees, like that. Thank you for watching. I am Method and I will see you in the next one. So until then, keep learning and coding. Thank you.